First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted my fellow fish heads. Wait a minute. That was last week. Actually, that's really funny now that we talked about cooked fish.
Cooked fish.
And there is
That's an inside joke, and we're not explaining it.
We can't.
Nope.
Right. But if you want to ask, we might not be able to explain it.
Yeah.
Anyway,
hang out in the IRC room.
Totally.
Maybe you'll
totally
find it.
Random. Hi, Roy.
Hi.
Roy doesn't know what cooked fish is either,
Mm.
but that's okay. So
Technically, I know what cooked fish is.
Right.
You only think you know, Roy.
You only
It's
think
fish
you
that
know.
has been cooked, but I'm assuming that there is more to it. With
But
YouTube
it's just
wacky
so
stuff.
ironic, and I wish I could explain. Okay. Anyway, so we had 2 awesome comments this past week. I thought I'd take a time to read them. The first one is from Travis Siegel. I hope I pronounced your name right, correctly. SoftCon on Parallax Forums. Comment, your Bite-Byte interpreter is almost identical to a language I ran across a year or so ago called Claw. You can find it on SourceForge at claw.sourceforge.net. I'd intended to port this to the propeller, but didn't know quite how to do it. Now, I can take your Bite-Byte and finish the port of Claw. There are samples of some songs, 99 bottles of beer, and some other things using the Claw language. The documentation is rather sparse and quite crude to boot, since the guy who wrote it was probably a 16-year-old kid who's mad at the world, but nonetheless it works and is actually quite fun. So just thought I'd point this out to let you know something like it is already out there, and just for FYI, really.
I'm guessing that the language that he's talking about is based off of the same language that is sort of the inspiration for Bite-Byte here. I added a few commands, but we can't actually say the name of the language that's the parent of both of those.
Why?
Because it involves profanity. It's brain screwed, only not screwed. Yeah, it's been around for a long time. It's a very well-known language amongst people who know esoteric stuff like this. It was the first super minimal one in the modern, era. I think it's like late 90s maybe.
Mm.
And it's actually basically a direct descendant of the work that Turing did during World War II when he first came up with this idea of programmable machines. It's not that much different from what a Turing machine would do. So there's a long lineage of things that work just like this, and that's one of the reasons why it's such a fundamental and cool thing for Addie to be working on, because it really gets down to the root of the absolute minimal that can do work.
Mm-hmm.
So it's
And
kind of cool.
Just so you know, you can actually look that up on Wikipedia, and it will show you the language and syntax and
Cool.
all that fun stuff.
Very cool.
But you have to search for the real name, not brain screwed.
Right.
Yeah.
Right. Fish heads.
A lot of people just call it
Brain
BF'd.
Right.
Yeah.
So, and I won't say what the F stands for. So, the second comment we have is from Paolo R. By coincidence, I just finished my first prop project, woohoo, which is a Core Wars environment with assembler/interpreter. You can find it on my blog above and in the project section of the prop forum, restlessengineer.wordpress.com. P.S. Good job, great show you have. Thank you. Actually, I think it might be kind of cool to see a Core Wars environment. Core Wars sounds
Core Wars.
awesome.
Core Wars.
Yeah.
Core Wars.
We like that.
So maybe we'll take some time next week and we'll take a look. Maybe we can take a look at that code if these guys haven't saddled me with another week of difficult homework. Which, by the way, I totally got like 90% on.
No.
Yes,
Fail.
maybe 80. No, 90%. 90%.
90% secretarial dictatorship.
10% was
90% procrastination.
what Look, let me just let you guys know. It is currently 3:50 a.m. Central Standard Time, and we had intended on starting recording at 1 a.m. Central Standard Time. It has taken these two genius experts 2 hours and 50 minutes to fix their bugged interpreter.
Oh, no, wait, back up. There was a extra delay after it was working.
Oh, was there?
And there was extra delay before I even started debugging it.
Well,
really only about
2 hours.
2 hours total.
2 hours.
3.
So I was working with buggy interpreter.
I had to fix Whisker's broken code.
Hey, no.
Now, I don't want to hate on him because, this
last
is
week
pretty
I was
difficult
very clear.
to write.
It wasn't really that difficult to write, but last week I was very clear that I hadn't tested it at all. Like,
Right.
I didn't even put it in the prop tool
Right.
to even see if it would compile or anything like that. So completely untested. That's fine.
It compiled.
Yeah, it compiled with no complaints. Didn't work.
So SoftCon, you might want to check the second revision.
Pay attention this episode so that you don't run into the same problems we did.
Right. So I'm just gonna let you guys know first that I took the time during our hackerspace time to write this code out, and the crafters who I was doing this around just stared at me and Whisker with very strange eyes because they had no idea what in the world we were talking about.
Yep.
I thought that was kind of cool.
Addie was actually talking to me in Bite-Byte.
Yes.
Asking me if programs would work while we were trying to entertain guests over this weekend.
Well, I was.
They think she's absolutely insane now.
I wanted to know.
So,
which is probably accurate.
Open bracket plus.
Yeah,
right.
Exactly.
It was pretty much.
Pound.
It was pretty much that. I said, is open bracket. So if open bracket compares the memory to 0, and if it's the 0, it skips to the close bracket. And if it's not 0, it does the next instruction. And the crafters pretty much just gave up after, I think, the first 2 words. And I totally get it. I understand. But that being said, so I wrote 2 programs. One was meant to increment from 1 to 255 just by 1, just for funsies. And then the other program was supposed to allow you to write any length of word or characters or sentences or whatever that you wanted to, and then also determine when you wanted to end that program.
Yeah, that second one is kind of awkward to use.
It's awkward to use.
Because you type one character at a time, and then in between each character, you have to type a number.
Correct.
And hit enter. And then the number has to be non-zero if you want to keep typing characters.
Correct.
So you type another character. But when it's 0, it ends the program, which means it just stops responding.
Actually, okay, look, I didn't say it was easy to use.
Not a very graceful program, Addie.
Well, this interpreter isn't very graceful, but if you, all you have to do, listen, all you have to do is type H1, enter, E1, enter, L1, enter, L1, enter, O1, enter, and you get hello.
I understand.
Yes, and it works beautifully.
But you know what you should have done?
No.
Figured out how to allow you to type until you hit some normally unused character and then exit when that character is there.
Maybe.
It's tricky though.
It's tricky. See, and that program fits in 6 commands. 6
characters?
Yeah, characters. 6 characters. Commands. So since
instructions.
Instructions. I was writing this out on a piece of graph paper. My program couldn't be that long, and I was doing it with pen and paper, so I didn't want to, Anyway, so let's talk about the interpreter, shall we?
The bugs.
So last week your homework was to write a sort of host program because the interpreter sort of is designed to be a module, right?
Yes.
An object that can be included in a program.
Yes.
Yeah. So, but we didn't have a host program for it. And your homework last week was to create a program that used it as an object.
Right.
How did that go?
With your help, it went pretty well. I started with the con section, with the OBJ section. That went pretty well.
There'll be links to the updated Bite-Byte object and the the host program here as well.
So
One thing we do know about the host program is Addie is very good at typing whatever Whisker tells her to type.
there are some things I didn't quite get, right? I didn't know how to set up the variables. Like, I know how to set up variables, period, but I didn't know necessarily why you have to set up variables if your object already sets up variables for you. But
Now,
I don't know.
because Bite-Byte is obtuse when it comes to everything about it is painful, right?
Mhm.
It wants your program that you give it through set program to be exactly 256
Yes,
characters long.
correct.
Exactly.
Yep.
Yeah.
And if you give it an address to, say, stuff in your dat section, and the stuff in your dat section is only 5 characters long, it's going to keep reading along and read whatever happens to be in RAM in
Right.
as your program after those 5 bytes. So you kind of have to be more careful about how you pass it the information that it's looking for when you set its memory or set its executable.
Right.
And I made an alternate version that you can be less careful with.
You can just hand it a string and it's smart
And
enough
it stops at the 0 at the end of the string.
Mm-hmm.
It's limited in that your program can't have any characters in it that are outside of ASCII range, but that's okay for now because the interpreter doesn't do anything with any characters other than the 7 or 8 that it knows how to work with.
Mm-hmm.
So
So
the
actually,
part in Addie's example program of how you can actually use the object, the part that she couldn't get on her own was how to take the stuff out of just a simple string in the dat section and how to feed it across into Bite-Byte. And I helped her with a little repeat loop that copies until it finds the 0 terminator at the end of the string, and then it stops copying it into a sort of temporary array, and then it passes that temporary array over.
So actually, why don't we just go through that code? Okay, can we just do that? And I have a question. What kind of program is this called? So the Bite-Byte version 2 is called the interpreter. What is this program called?
This is just glue, man. It's
just a program.
It's just okay. All right. Well, I'm not gonna call it program, but I'll call it
host Bite-Byte host.
Okay, I'll call it Bite-Byte host. Sure.
It makes sense because your actual program is the string that's in the dat section, but this program is just a way to load Bite-Byte up with your program and run it.
So you need like 30 lines of spin just to feed in your tiny little 5-character program into Bite-Byte.
Technically, it's only about 8 lines of spin. I mean, the con and the obj and whatnot are sort of not.
Okay. So let's go through this. So con section we know, object section we know. I just called it byte, like bite. Zombies biting your face off, bite. Var section we set 2 longs, one for memory 256 and program 256 because, like Whisker said earlier, it has to be 256. The memory has to be 256. The program length has to be 256 bytes.
Now, obviously, for those of you out there who are wanting to sort of modify this and make it work with other similar languages, those rules don't have to be that way. You can obviously change it to behave how you want it to.
Right. Okay, so then we have the pub main, which has a local variable index, and then we do a wait count of 1 second.
Just to allow you to turn on the serial terminal.
Right. And then this next portion is taking your whatever is in your dat section and transforming it into a 256 byte.
No, 256 long.
Or 256 long.
It takes each byte and puts 1 byte in each long in the array for the program.
Right. So you're taking your little dat program and essentially translating it into something that will work with this interpreter.
And the reason that it's going into longs is because we don't use signed bytes, but in spin the byte is signed. So if you copied it into a byte, then you'd have like negative numbers and stuff
Essentially, the
wouldn't work out.
Bite-Byte virtual machine uses unsigned bytes.
Right.
And I couldn't do that directly in Spin because Spin uses signed bytes.
Mm-hmm.
So I'm using longs to contain
Okay.
the unsigned bytes of
Okay.
the
Right.
virtual machine.
Okay.
Right.
So-
We could have used words, which would have saved a little bit of memory, but it's not a big deal.
Okay. So we repeat the index from 0 to 255 where program, it's like you're looking at the program 0 and you're saying, okay, what is the equivalent in trial 1, 0? Then
Right.
then you move on. Program 1 : equals trial 1, 1.
Yeah.
Program
It's
2
just
equals
copying the
trial 1,
bytes into
2.
the longs.
Right. And then if the program index equals 0, then quit. So essentially if you look at the dat section, you have whatever you have in the quotes and then you have that 0. So once we get to that 0, then it gets out of that repeat loop.
Yeah, and the other part of the reason this happens to work is because var section variables
Mm-hmm.
are all initialized to all zeros. So we don't have to pre-initialize that program array with zeros because it's in the var section. It's global, and those are pre-initialized.
Okay. And that will come into play because that was an assumption that was made for local variables.
Are not,
Yeah.
Apparently, local variables are not initialized to 0.
Well,
What
yeah.
are they initialized to?
they're not.
They are not initialized. They're whatever happens to be on the stack
Oh,
at the time that the program is executing when it gets there.
I see.
So you have to make sure
You have
that
to say index equals
initialize.
0.
You have to initialize your local variables to something.
I see.
So we had to do that in the execute function,
Okay.
which we'll get to later.
Okay, and then so we go to byte.start, which starts the parallax serial terminal. Then we do byte.set program, and then we point to the program at program. And then I'm going to skip the commented out portion. We'll talk about that in a little bit. And then we byte.set memory, and then we set the memory to the memory.
And in this case, it's just all zeros.
Correct, because again, the variables initialize to 0.
Because
and then,
they were in the var section.
Right.
Yeah.
And then byte.execute, which just runs the program. So what you do then is you run this program, you load it into your EEPROM or your RAM on your prop, and then you open up your serial terminal, and then you can pretty much see it, depending on what your program is. I mean, if you load one of my programs, you'll probably see the numbers count up.
Right.
Right. And
you'll post in the link, you'll probably have the one that just counts up.
Right. And I can show I'm putting in the dat section trial 2 so people can look at both of them, but
Right.
So the first one will just show this program that I wrote plus open bracket # plus close bracket.
And to correct you, you wrote it a slightly different way, and I changed it to that.
Yes.
The way you had originally written it with the plus open bracket plus # close bracket would have started the displaying at 2 instead of 1.
Right. So what this does is essentially it goes to your memory. It looks at your memory number, your first slot in memory, which is initialized to 0. It pluses 1, so that increments, so it goes to 1. And then it goes to open bracket, and open bracket pretty much says, well, is what we're looking at in memory 0? If it's not, then go to the next instruction. If it is, then go to the closed bracket. But obviously,
the first closed bracket that you find after this open bracket specifically.
Right.
Because you can have nested loops.
Right. So right now we're at 1. So obviously it's not 0 when we get to the open bracket. Then we go to #, which prints that out. So on your serial terminal, you'll see 1. And then we go to the next instruction, which increments again. So we go from 1 to 2. And then we go to the closed bracket. And the closed bracket, all it does is it takes you back to the closest open bracket. And the open bracket again says, well, are we 0? No, we're not. We're at 2. So then we keep incrementing with a maximum of 255 for this interpreter.
Because the interpreter caps the number at 255 and just keeps setting it back if you try to make it go higher.
Right.
One other thing to be aware of, it's something that is just a bug in the interpreter technically, or just an undesigned feature, is that the nested loops won't actually work.
Sure they will.
I don't think they will.
No,
Yeah, they
because
will.
it searches for the first close bracket. And
I'm
if
smarter
you have,
than Ray.
okay.
I don't know.
Well, they will work oddly. How about that?
Yeah, well, everything works oddly about this
All right,
language.
you might have to show me
one of the
we can talk
tricks
about
that you use to make the nested stuff work is by having more than one memory address that you're using for your checks. That helps a lot. But yeah, you can make it do nested loops. It's not fun though.
I see.
Yeah. But if you just do the naive approach of open bracket,
you're going to get...
and then close bracket, it will never work right.
Yeah. It'll only do the internal one.
Yeah. The thing that I don't understand is how when the open bracket is deciding that it's going to go to the close bracket, it searches for the first close bracket and gets to there, and then that close bracket is going to go back and find the open bracket, which will give it the first one it finds. So it'll be bouncing back and forth.
Yep. So you can't do nesting like you do in C++, which is what Roy's used to doing. It doesn't have that functionality, and you should try to understand that, Addie.
Yeah.
What we're talking about here is that one of the features of higher level languages is that you can have a loop inside of a loop, right? You can get the same functionality out of this language, but you can't do it by putting the loop inside of the other loop.
I know.
They have to be next to each other.
Right. Yeah. I know. That's why I wrote my hello world code the way I wrote it, because nested loops just So, do you guys want me to explain my other code, or should we go to the interpreter?
We've only got a couple minutes left here, and I think we should probably talk about a couple of the bugs that were in the first version.
All right.
Right.
Probably a good idea.
Okay. So, we got
the first one is really simple. In the case loop, the actual like execution loop there, there wasn't a case, what do you call it? Other, where it was incrementing the execution pointer in the case that the symbol that it was currently at in the program wasn't a recognized symbol in the program.
Right.
And of course, we're initializing all of those zeros, so we do need to handle them. And the intention was always that white space should be ignored in this programming language, and 0 would be considered white space. So that's just a 2-line addition to the main loop, and that fixes that problem.
Just to explain, that's a standard thing in Spin. The other colon is the catch-all that is,
it's like else.
Do a case and if it doesn't match as any of the cases, then other is what it will do instead.
It's kind of like if, then, else,
where is this?
And then last one, else.
It's in the execute function at the bottom of the Bite-Byte interpreter, Addie.
Okay, I'm looking at it.
See where it says other : exep++? You're looking at the correct version of the code?
Yeah, the one you gave me. Oh, I see.
Yeah,
I see.
So if there's an instruction that it doesn't recognize as an instruction, it just increments the instruction pointer forward, the execution pointer we called it.
I see.
Right. The other problem with the execute function is that the exep and memp variables needed to be initialized to 0, so those are added right at the top there.
And that's the local thing that we mentioned earlier.
I see. Okay.
Right. Then the one additional thing that I put in here just to make it easier to see what was going on when we're debugging is that there's a small delay for every instruction, but you could comment that out if you wanted to go full speed.
Yeah. Okay. And it can be pretty snappy. I mean, not that you would actually want to use this for anything, masochists.
Yeah. No, I think you guys also...
There was also a problem with the set program and set memory pubs.
Yeah.
The post increment on the left-hand side of the assignment was behaving strangely.
Well,
We didn't figure out if that was it or not. Roy's not sure.
Yeah, I'm pretty sure it's not that. I'm pretty sure it was just that the exep variable is being used a couple of different times there, and maybe not wasn't the value we were expecting at the right time. So I changed it around to work a little more clearly.
It's now done like you do it in like basic.
Right. You have a loop that you count up, and you just index each thing by the loop. The other thing is I change it so it doesn't actually do the address plus plus. It doesn't modify the passed in address. It just uses the index, which is the syntax from the spin manual for when you're using long like that. So long open bracket address close bracket says that's the base address. And then the second open and close bracket with a number in it or variable is your offset from that base address. And it will automatically do the offset as multiples of the size of the thing. So in the case of
Which
a long,
is handy.
It automatically does it as multiples of 4. If it's a word, it automatically does it multiples of 2.
Yeah. And we did cover this functionality way back.
Yeah.
I'm sure Addie doesn't remember. But we have talked about that one before. You can do the offset.
The one last additional thing in here is that I added a set program from string function, which is just a little bit simpler, easier way of doing it, which we talked about earlier in the program, where you can pass a string in and it will handle the reading the bytes into the long memory of the executable and stop at the first 0. Again, it has a limitation of it can only handle ASCII characters, and it stops at the first 0.
Yep, and that's because of the whole signed unsigned thing.
Right.
If the propeller really loved me, it would have unsigned bytes. But it's a point of contention with us. Me and the propeller. It's a rocky romance.
Mhm.
All right, so we've only got a couple minutes left here. I gave her some homework last week, Roy. How about you give her some homework with this sucker for next week?
Wow. Well, for one, I'd like to see something more than 4, 5, 6 character program.
That's a very powerful program. Thank you very much.
I know, but
Yeah.
you could do better than that. So
Meh.
assignment 1 is something a little more interesting. Maybe print out a string and get a response, and then print out a result from the response. Something a little more there. I know you're limited by the exe part, but you could use the memory initialization to help with some of that too.
Okay.
So that it's sort of coordinating the memory and the executable code together is an important thing to understand. So
Okay.
I would definitely say to do that. And then maybe while you're doing that, take some notes about some features you think would be useful in the interpreter that would make it easier to program.
Nested
that's
loops.
where we're going.
Longer
'Cause that's what-
string characters allowed.
Well, just, think about it, and then we'll talk about them next time. You got to think about, like, as you're writing this program, what kinds of instructions would make it a little bit easier to do. And so you don't have to do all these
Yes.
weird convolutions.
Bite-Byte is very much designed to be a torture implement. Okay? So just by using it, the places where you feel the most pain are the
Mhm.
places where you should be thinking about, well, how could I make this better? Because this is absolutely terrible.
Mm-hmm.
And think, in a couple weeks' time, maybe 2-3 weeks from now, we're going to have you adding commands to that case statement in the execute.
Oh God.
So you'll have your own instructions that do stuff.
Well, okay, fine. I will attempt to make a better thing that causes
Better example.
a better example that causes the execution program and the memory program to dance around each other. But you guys have homework too, which is to figure out a way to explain Bite-Byte version 02 in a more normal manner. Because whatever you guys just said completely went over my head.
We weren't really explaining it in
To
a
me.
way. Yeah. We were just letting, because we know that there's a few guys out there that are actually kind of using this for something, and we want to make sure that we let them know, why the things that were broken, because they're actually good little things to know about how spin behaves.
Right.
Right. And we'll go over it with you so you understand it in more carefully.
Okay.
All right. Well, that's all the time we have for this week, everyone. Thank you for listening. We very much appreciate it. You guys can find this show every Tuesday at firstspin.tv. There's an RSS link there on the page. You can also listen to it right there, too. RSS feed is handy if you want to get it on your phone automatically. I know a lot of people listen to it in the car on the way to work and such. Yeah. Anyway, that's it for us. We'll see you guys next week.
Bye.
Bye.
See ya.